Let's dive into a seemingly simple yet profoundly deep question. Why does the area of a circle equal pi r squared? I mean, really think about it. Whenever you need to find the space inside a circle, your brain automatically spits out pi r squared. It's practically hardwired into us from middle school. But if you take a step back, it's a little weird, right? Like, where does the pi come from when we're just talking about flat area? And why on earth are we squaring the radius? Instead of just accepting it as some rigid, untouchable rule, we're going to deconstruct it. We're going to see, literally with our own eyes, why this equation is the absolute, inescapable truth of a circle's geometry.
Okay, let's kick things off with Section 1, the circle area mystery.
We start with nothing more than a simple, clean circle. To figure out its area, we really only need to track two very basic properties. First, the radius, which we call r, stretching from the center right to the edge. And second, the circumference, c, which is the total distance around the outside. Every single step of our little transformation today relies entirely on just these two components.
Moving right along to Section 2, slicing up the circle. Now, this brilliantly illustrates the core of our transformation. We're going to slice this circle up just like a pizza and then interlock those pieces to build something completely different. Picture taking our circle and cutting across the center over and over, making a bunch of super thin sectors. They look exactly like really long, skinny pizza slices. Now, imagine pulling all those slices apart. Instead of leaving them in a round pie shape, we rearrange them. We take one pointing up, drop the next one pointing down, the next one up, and so on, interlocking them tightly in a straight row. It's a wonderfully simple, mechanical action, but it completely changes how we view the boundaries of the shape.
Which brings us to Section 3, reshaping into a rectangle.
Now, what's really fascinating here is how we can map the original traits of our round circle directly onto this totally new shape. Notice that we haven't added any extra space, and we certainly haven't taken any away. The entire area that was inside that original perfectly round circle is now sitting right there inside this jagged interlocking shape that, well, it strongly resembles a rectangle, doesn't it? Actually, if you imagine slicing the circle infinitely thin, those slightly curved pizza crusts flatten out completely, and our shape becomes a perfect smooth-edged rectangle. The total area is exactly the same. It's just wearing a very clever disguise.
If you look closely at the sides, you'll notice the height of our new rectangle is exactly the radius r. Think back to how we cut those pizza slices earlier. The straight, cut edges of every single slice run right from the center of the circle straight out to the perimeter. And that measurement? That's exactly the radius. When we stand all those slices up and jam them together, those straight edges now make up the vertical sides of our new rectangular shape. So the absolute height of this rectangle is simply r.
Now for the base. Since the full circumference of a circle is 2 pi r, half of it ends up forming the bottom base, leaving us with a base of exactly pi r. Let's trace it out. Remember the crusts of our pizza slices? When we interlock them, half of those curved crusts pointed up, forming the top of our rectangle, and the other half pointed down, forming the bottom. We know the total distance around the whole circle, the circumference, is 2 times pi times the radius. So the bottom edge of our rectangle, which is only made up of half of those crusts, has to be exactly half of the total circumference. Half of 2 pi r? That leaves us with a bottom base measuring simply pi times r. All right, time for Section 4, solving the math.
We can even test this concept out with some real data. Say we give our circle a radius of exactly 3. Standard math tells us the area is roughly 28.27. Well, if you take that exact same radius and map it onto our newly built rectangle's dimensions, the physical space behaves identically. The numbers hold up perfectly. It's solid proof that the standard math completely matches our visual deconstruction.
So let's see how this all builds together. We all know probably the easiest formula in geometry, right? The area of a rectangle is just base multiplied by height. Well, we've just visually proven that the base of our transformed pizza slice shape is pi times r, and its height is simply r. So to find the area of this entire shape, which remember holds the exact same amount of space as our original circle, all we have to do is multiply our new base by our new height. And right here is the magic moment. By multiplying those together, we arrive at our beautifully satisfying conclusion. Base times height becomes pi r times r, which gives us exactly pi r squared. By literally squaring the circle, by physically rearranging it into a standard rectangle, we seamlessly derive the very formula we've had memorized for years. It's not just a random string of symbols anymore, is it? It's a perfectly logical visual outcome of unpacking a circle into straight lines. The area of the circle equals pi r squared. I really hope this explainer leaves you wondering what other complex ideas can be unlocked just by looking at them from a totally fresh perspective. We took something universally accepted, something we rarely visualize, broke it apart, and found simple, foundational geometry hiding right there inside it. It honestly makes you think differently about the rules we just take for granted. I mean, if a shape as famously curved and endless as a circle can just be unfolded into a neat little rectangle, what other rigid mathematical rules are actually just brilliant, simple visual tricks waiting to be discovered? Thank you so much for exploring this with me today. And hey, always keep questioning what you see.